P is inside equilateral triangle ABC. PA equals 3. PB equals 4. PC equals 5. Find the area of triangle ABC. This video contains the following sections: reading the problem carefully and understanding it, developing a plan to solve it, solving the problem, thinking about it further, and try to apply the approach to other problems. Near the end of the video, there's an additional question which can be solved using a similar approach to that used for solving the specific problem. If you find these helpful, please subscribe to the channel for notification of new videos by pressing the video watermark in the right-hand corner of the video player. Because triangle ABC is equilateral, so AB equals AC equals CB. Angle BAC equals angle ACB equals angle CBA equals 60 degrees. PA equals 3. PB equals 4. PC equals 5 are given, but these can't be used directly to calculate the area of triangle ABC. The area of triangle ABC can be worked out if its side length, A, is known. Area of triangle ABC equals a half A squared sine 60 degrees. Focus on triangle APB, triangle APC, triangle BPC. Each has 2 known sides and 1 unknown side of length A. If angle APB or angle APC or angle BPC can be worked out, we can then work out A. For example, if angle APB is known, then A squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of angle APB by the cosine law. How to work out angle APB? Because PA squared plus PB squared equals 3 squared plus 4 squared equals 5 squared equals PC squared. So a triangle with lengths PA, PB, PC must be a right-angled triangle. But here, PA, PB, PC don't form any one triangle. We can rotate triangle BAP so that a triangle which has PA, PB, PC as side lengths can be constructed. Rotate triangle BAP 60 degrees clockwise about B. Triangle BAP is rotated to triangle BCP dash. So angle P dash BP equals 60 degrees angle CP-B equals angle APB. P-B equals PB equals 4. P-C equals PA equals 3. P-B, P-C, and PC still don't form any one triangle. Connect PP-, we can prove triangle PP-C is a right-angled triangle. Focus on triangle BPP- because P-B equals PB. So triangle BPP- is isosceles. So angle BPP- equals angle BP-P, because angle PBP- equals 60 degrees. So angle BPP- equals angle BP-P equals 60 degrees. So triangle BPP- is equilateral. PP- equals PB equals P-B equals 4. Focus on triangle PP-C, because PP- squared plus P-C squared equals 4 squared plus 3 squared equals 5 squared equals PC squared. So triangle P-C is a right-angled triangle. Angle PP-C equals 90 degrees, but the converse of Pythagoras Theorem. Angle CP-B equals angle PP-C plus angle PP-B equals 90 degrees plus 60 degrees equals 150 degrees. So angle APB equals 150 degrees. Let's BC equal A. So AB equals A. A squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of angle APB, which is equal to 9 plus 16 minus 24 cosine 150 degrees, which is equal to 25 minus 24 times minus root 3 over 2 equals 25 plus 12 root 3. Area of triangle ABC equals a half A squared sine 60 degrees equals a half times 25 plus 12 root 3 times root 3 over 2 equals a quarter times 25 root 3 plus 36 equals 9 plus 25 root 3 over 4. Think about the thought process for the previous question further and try to apply the approach to other problems, such as this one. Triangle ABC is equilateral. P is inside triangle ABC. PA equals 3. PB equals 4. PC equals 5. Find the area of triangle PAC. You can write your answers in the comments section if you like. Can you think of other problems that can be solved using a similar approach? Thank you for watching. Hope you found this video helpful. See you next time.